Okay, in this video, I'm going to discuss about the Pinacol rearrangement. When 1,2-diol is treated with acid, the following rearrangement happens. The diol is converted to a ketone. This is the mechanism. The first step is the protonation of OH, which leaves us water to give the carbocation. This carbocation, like any other carbocation, will undergo rearrangement to give the more stable carbocation. And the presence of this OH can assist that rearrangement. So the migration of methyl group is assisted by the lone pair of the oxygen to give you this species, and which can just lose a proton to give you the final product. Now let's discuss the different aspect of the reaction or the rearrangement. Now in this substrate, we don't have to worry about the choice of protonation because both the OH group are equivalent. But what about this one? Uh, the choice of protonation also decides the choice of migration. So how can we decide which OH group should get protonated? The protonation of OH depends upon the stability of the carbocation that is formed. So so we just have to decide. For example, if I protonate this OH, I'll get this carbocation. If I protonate this OH, I'll get this carbocation. So apparently this is more stable carbocation than this. So the protonation of OH, this OH is the best choice. And then that also decides the migration of this reaction. So here, this is the final product and you get 99% of the yield, which means the reaction goes through this way and not this way. And there are other type of reaction called semi-Pinacol rearrangement. So in this reaction, in this rearrangement, we had an ambiguity, either I should protonate this or this. Semi-Pinacol rearrangements have no choice. They can be directed only in one direction, which means the choice of carbocation is already fixed. For example, in this substrate, under the reaction condition, a carbocation can be only formed from this carbon and not this carbon, and so the reaction can only go in one direction, and you get this is the final product. The last important aspect of this rearrangement: which group should migrate? Sometimes you have a choice of migration. For example, in this case, either this group can migrate or the hydrogen can migrate. But what's the criteria? The migratory group should be anti-periplanar to the living group. So for this substrate, the hydrogen is not anti-periplanar to the living group, so it cannot migrate. So this bond should migrate and you get this is the final product. Even for this substrate too, the same thing happens. So again, a hydrogen is not anti-periplanar to the living group, so this group should migrate and you get this as the final product. See, this is not migrate, the hydrogen cannot migrate, so this group is migrating. Here too, again, this group is migrating. Let's look at this one. In this case, the hydrogen is anti-periplanar to the living group. So hydrogen can migrate and give rise to this product. Then what about this one? In this case, neither hydrogen nor this group bond is anti-periplanar. So there is no way of migration. Instead, the lone pair directly attacks this carbon and you get the epoxide as the final product. That's all with the Pinacol rearrangement. Thank you.